Hello everyone. Today we will take a look at DIY proof of concept project Smart Energy Saver Circuit, which is published on electronicsforyou.com. Link to the project is in the description of this video. Ever left your mobile phone or laptop charging overnight? I think we all have. But do you know keeping devices plugged in longer than necessary can wear out batteries and waste energy? Today, we are going to show you a simple, yet effective solution to avoid these issues, a circuit that automatically cuts off power to your devices once they're fully charged. This is our automatic power cutoff circuit. It's designed to disconnect any device connected to the AC mains supply automatically after a set period. You can adjust this period from 1 to over 4 hours based on how long your devices usually take to charge. It prevents overcharging and reduces energy wastage. It also improves the device's battery health. So, how does it work? Let's take a look. This is our prototype. This is the reset button. This LED is representing the device. When this LED is on, that means the device is on. After some time, the LED turns off automatically, representing the device turns off. This is the perfect project for everyday consumers using smartphones, laptops, or tablets, making it a practical addition to any home. The technology aligns with green values by cutting down on power wastage. It's also an excellent project for tech enthusiasts who enjoy customizing their gadgets, with adjustable delay times made possible through simple resistor changes. The circuit can also be installed at offices and educational institutions, helping to manage multiple devices efficiently. Amazing, right? But how to make this? You can make this with very few components. Let's take a look. The 1 farad 2.7 volt supercapacitor is the primary timing element, charging through a resistor to set the delay. It provides longer delay times due to its higher capacitance values in comparison to standard capacitors. Relay is used as a switch that switches the connected device on or off. LM358 op-amp IC compares the voltage across the supercapacitor with the reference voltage and controls the output that triggers the relay. Here the op-amp works as a comparator. A to N3904 NPN transistor acts as a switch driven by the op-amp. It energizes or de-energizes the relay based on the comparator's output. Switch is used to reset the circuit by discharging the supercapacitor, allowing for immediate reuse of the timer function. A potentiometer allows for adjustment of the reference voltage at the non-inverting input of the op-amp, enabling variable delay times. A few resistors are used to control the rate at which the capacitor charges. To assemble the circuit, follow the circuit diagram. Arrange all the components including transistor, resistors, op-amp, diodes, relay, LED, switches and potentiometer. Now use jumper wires to connect these components following the circuit diagram. Once the circuit is assembled, you can test the circuit after turning on the power supply. Once you press the reset button, the supercapacitor discharges and the timer function is available for reuse. The LED is on and it turns off automatically after a fixed time duration. Voila! It works. So, what did you learn? How to build a timer circuit with a supercapacitor for long delays. How capacitors, resistors, diodes, and transistors work together in a circuit. How to use diodes and LED to manage and show voltage levels, preventing damage. How to use op-amps for voltage comparison. How to use a potentiometer to adjust circuit parameters. Interested in developing your own smart energy saver circuit? Then click on the link provided in the description of this video. Do like, share and subscribe to our channel for more such DIY proof of concept videos. Thank you.